All right. Well, switch over here to the video. So this is Andrew Loke. He is going to be explaining basically what he calls his modus tollens argument against, or I guess in support of the first premise of the Kalam.
As we all know, if an argument is deductively valid and the premises are true, the conclusion must be true. The conclusion is true, right? This follows from the laws of logic. And the modus tollens argument is deductively valid form. If P, then Q, not Q, therefore not P. And so my argument goes like this. If something, say for example, X begins uncaused, then some other particular things, such as Y, which began or could begin to exist around us, would also begin uncaused. Because if something begins uncaused, that means that there will be no cause, which makes it the case that only X rather than Y begins uncaused. And moreover, the properties of X and the properties of Y, which differentiate between them in the concrete world, this differentiation will only be had by X and Y when they have already begun to exist. And therefore, this implies that there will be no difference between X and Y where beginning to exist uncaused is concerned, given that the circumstance around us is compatible with the beginning of Y. It doesn't prevent the existence of Y. We would expect to see Y also beginning to exist uncaused if X begins uncaused. However, it is not the case that Y begins uncaused. So for example, we don't experience a sudden increasing in strength of electric field around, beginning uncaused around us and killing us. And moreover, we also don't see another universe beginning to exist uncaused and crashing into our universe, for example. Right? We don't see such things happening. And therefore, it is not the case that X begins uncaused. Right? This follows from modus tollens. And so this implies that whatever begins to exist has a cause. In fact, whatever begin to exist will depend on the cause, to be the case that it is X rather than Y that begin to exist. Right? So this is the modus tollens argument for the causal principle.
Any thoughts so far there, Rick?
Yeah. So first of all, I'm sure a lot of the audience are confused already. And I have to warn you, this is kind of the most coherent of Lokeism. Like I quote a paragraph in his book that is hair-crawlingly unintelligible compared to this is really confusing, hard to follow. All his writing is like this. And when I read it at first, when I read the book and then his follow-up article to my article responding to the book, I tried really hard to be charitable, to like try and figure out what could he mean that makes sense. And so it is difficult. Reading him is difficult. And if you followed him right there, all the power to you, because that was difficult. He also dropped some things here that maybe he went into more detail elsewhere in the video, but the first thing he starts with is so the modus tollens. So that's an actual argument form. He's correct. Like modus tollens works the way that he talks about it. It's basically works like a scientific model where you say, well, if the hypothesis is true, it predicts these observations, A, B, and C. He says Y. It predicts Y. So if X is true, it predicts Y. But you say, if this hypothesis is true, it predicts certain things. And if we go and look and those things aren't there, then X has to be false. Right. Now, he's confusing a bit between inductive and deductive logic. And because they're obviously, as science has learned, it is possible for the hypothesis still to be true, because maybe you got something wrong about the hypothesis. Maybe there's something wrong with your instruments, and so on. Right. There's a variety of ways that the tollens can fail that are inductively related. So, but here he's talking about, like, if we assume what? Oh, I'm sorry.
No. Sorry, it accidentally
started again. Okay, yeah. So anyway, but it's fair enough. We can say that, strictly speaking, if we set aside all contingencies like instrument failure and hypothesis adjustment and all of that stuff, strictly speaking, if a hypothesis predicts Y should appear all the time and we don't see it, then X is false. And inductively, that's a reasonable argument. Even probabilistically, you can make a Bayesian argument, etc. So we'll follow him along there. So I agree if that's the case. If a hypothesis makes a prediction and the prediction doesn't carry through, that is evidence against the hypothesis. So fair enough. Okay, so then his argument proceeds to, well, if the causal principle was ever not true, then even now we should constantly see random things popping into existence everywhere, right? So we should see random rabbits, we should see like Beethoven's Death Star should suddenly appear. Like, I don't remember the exact examples he gave, but it's the same. We should see these whole houses should be materializing, planets and stars, everything should be like spontaneously occurring right now. Well, this is not a prediction of the hypothesis, right? So like, yeah, before the causal principle applied, the causal principle didn't apply, but once it gets caused to exist, then it applies, right? So like that counter predicts Y, right? Like you're saying, like now we're living in we can't see nothing now because we're 14 billion years away from it. Like it was 14 billion years ago or more if it's multiple universes before that. So we're nowhere near nothing. We can't observe it. We are in a principled propertied space-time, right? So we're in an ordered space-time that is controlling what can and cannot happen. So yes, the causal principle applies now. We do not expect to see random rabbits and all of this stuff because we live now in an ordered space-time. But the whole point is, like, if the principle didn't apply before it applied, which logically it won't have done, right? Because it can't exist before itself, in that point, in that regime, in that epoch, in that time of existence, then yeah, your rabbits should be popping into existence, etc. I talk about the probabilities of all of these things, of tigers and rabbits and universes and all of that stuff. Yeah, back then we should observe that, but we don't live there. We can't see back then, right? We don't have telescopes we don't have time travel. We can't do any of this. All we can observe is what happens in an ordered space-time. And an ordered space-time has a causal laws, right? It's driven by causal laws. We can actually even infer those causal laws as emergent from ultimate randomness. I have a different article I didn't put in the links that I gave you, which is linked, I think, in one of them, but it's about how all the laws of thermodynamics are inevitable. But set that aside. Loke never goes there, so we don't need to worry about it. The point being is that his argument is bollocks, right? Like, he's saying like that even though the causal principle, we all agree, he and I agree, the causal principle now applies everywhere we can look because it's an ordered space-time. Therefore, but they should still be random things appearing everywhere. It's like, no, that's not a prediction of the theory. That doesn't make any sense, right? Like, yeah, sure, it would make sense 14 billion years ago or 100 billion years ago or whatever it was. Yeah, it might have made sense back then, but we're not there. We're not observing it. So the modus tollens doesn't even apply, right? It's complete bollocks. Like the prediction, the Y is not predicted by X. And that's where he goes wrong. And he throws some other things. He mentions some other things that he goes into more detail. And I talk about in the articles, like we should see universes crashing into each other everywhere. And it's like, that's not a prediction of the model at all. Like, it doesn't follow at all. I don't know where you're getting this. It doesn't make any sense. You're not doing any math to calculate, like, how many universes, how big are these universes? Why are they colliding with our universe? Like, it doesn't predict any of this. It's complete bollocks. And it's frustrating. And I tried to explain this really hard. I tried to explain this in the debate, and he would just ignore everything I said and just keep repeating the arguments over and over again as if I didn't say anything. And that's why I'm tired of dealing with Loke. But anyway, that's what's going on here. I think there are a few more points. He has 4 arguments. I don't know if he mentioned 2 here. One was the universes be colliding into each other. We'd see a whole bunch of collisions. And then the other is that we should see random rabbits and planets and stuff appearing everywhere. Or he mentioned here the strength of the magnetic field should just change randomly. It's like, no, that doesn't follow at all. That's so, yeah, it's frustrating. Anyway, so he had other ones. I can't remember what the other 2 are, but they're addressed on my articles. He might get to them later in the video. I don't know if your other clips show it, but that's his argument. So that's, you see the problem I'm having here.
Well, yeah, no, I trust me. And I mean, he's actually going to address this a little bit later because he feels like you just simply don't understand the words that he's saying. Yeah. And that you've misrepresented what he said.
Let's give him a shot to explain that.
I wonder, would you mind if I ask you a question on this? So there's a version of this argument that I've read in Necessary Existence that was co-authored by Josh Rasmussen and Alexander Pruss. They've got an argument, I think they call it the argument from chaos. I can't remember the exact name. That may be actually the exact name that they use. But basically, the argument that they use is that suppose that something can begin to exist uncaused. Now, the question would be, what sort of amount of things could fit into that category? So there's a category column, things that can begin to exist uncaused. Okay, that category, either, like, if you think that something can begin uncaused, you got to believe that there's at least one thing that can fit into that category. But then the question would be, how many things would actually be in that category? And there's not really a reason to limit it. There's no reason to think that only one thing could exist uncaused. So you'd probably have to believe that that set of things that can begin to exist uncaused is like infinitely large. And then the next step in their argument is to say, if that set of things is infinitely large, then we would actually expect to find things popping into existence uncaused out of nothing all the time, because that set is so large, and there's, it doesn't discriminate of like different times of when it comes into existence or anything like that. So that's maybe I don't get all the details right there, but that's sort of a summary. Seems like it's actually pretty consistent with what you argue here in your modus tollens argument. I wanted to kind of get your thoughts on that.
So what do you think of this?
Much better stated. Say we have a much more easy to listen to and understand person trying to steelman what he said. That is essentially what Loke is saying. The problem, though, is that the condition, the prediction, only holds when the condition does not apply and where the condition does not apply, right? So you say like where there is not oxygen, you do not expect to see fire, right? Obviously, I know there's chemical exceptions to this, but let's just say standard oxidizing fire. No oxygen, no fire. And then you come around and say, well, that can't be because then we would see fire everywhere, even where there's not oxygen. It's like, that doesn't make any sense. No, obviously when there's oxygen, you'll see fire. Yes. But when there's not, you won't. And now imagine it's a universe where there is no place we can go to not observe oxygen. Oxygen is just everywhere, right? Then you can't say we should see it everywhere. We shouldn't expect to see it at all because we can't find the place that lacks oxygen to observe what would happen there, right? And so that's what they're not getting, right? Is this idea that, yeah, now here where we are, there's a principled ordered space-time that limits what can happen and limits it in specific ways, like quantum mechanics, even spontaneous quantum mechanics and stuff is limited in very specific ways. Only certain kinds of things can be here and happen here and so on. But that's here, right? Where we are now. The question is where did that come from? What existed before that? And you can't say that the causal principle existed before that. Or certainly can't exist before itself. So there had to have been a time when the causal principle hadn't come to exist yet. And at that time, yeah, you'd see all kinds of this stuff popping into existence. But the reason we don't see it is we don't live there, right? Like that's so far in the past. It's beyond the wall of the Big Bang singularity. We can't see that. So obviously, that's why we don't see things. So the argument from chaos makes no sense as an argument for the first premise, for the first premise of the Kalem. And this is the thing that Loke never understood, even though I explained it to him and I reworded it multiple different ways, multiple different times. I just couldn't get him to see it. He just ignores it. And notice that's what he's doing now. He literally just blown past everything I just said and just literally repeats the argument I refuted. And that's it. Like he doesn't explain what my refutation was. He doesn't respond to the refutation. He hasn't updated his presentation to be immune to my critique. He's done literally nothing. He's just literally repeating himself over and over and over again. Talking with someone, engaging with someone like that, you get tired of it after a while. Like you can't expend any more resources on it.
Yeah, I totally agree. And it seems like it's this weird thing because it seems like from what I've seen in this interview that Loke understands what you're saying. He's just totally choosing not to acknowledge what you're saying. Like he later on in the interview, he actually says, well, this is what Carrier says. And I'm like, well, from what I've read, yeah, Loke is pretty, steelman-y about it. He just totally ignores the fact that you've said anything and then continues on with because of, my modus tollens thing, blah, 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 blah. And he keeps on going from there and he just totally ignores your entire argument.
Yeah. It's frustrating. Like imagine having done that. I've gone through this 3 times now. Well, this makes 4. It's tiring. Yeah. But I don't know what to say. Like I've tried the hardest I can to steel man what he's saying. And it's just no way to make sense of it.
Right. No, I totally agree. Well, there's a little bit left in this particular clip. I think they're going to interact a little bit more on his initial argument, I guess, for the causal principle right here.
Yes. The argument is pretty similar to mine. But I read the argument quite a while ago, so I can't remember the details now. And I am not actually prepared to discuss the argument today. But if I remember correctly, I think the argument is based on certain idea of whether something can begin to exist uncaused, and if something can begin to exist uncaused, other things can also begin to exist uncaused.
Pause right there. That's okay. Yeah. So when he says when things can begin uncaused, we should observe things beginning uncaused. Notice when things, right? Like he says like if things can begin uncaused, as if he's ignoring time location, right? Like this. But no one's saying that it's always the case in every possible location. They're saying like there was a time once. It's not around here. We can't see it with any telescope. It's a long freaking time ago. There's a massive firewall between us and it. Long time ago, things could arise uncaused until something did arise that was governed by a causal law that resulted in evolution of the cosmos into, humans and planets, stars, planets, humans, the whole cosmological story, which you need a causal law for that to happen. So like in complete chaos worlds, like worlds that aren't governed by a causal principle, none of that stuff can stack and develop over time. And thus you will never have observers in those worlds. You need stability, and you need causal stability in order for stars to form and stick around, planets to form, elements to form and stick around. And you need all of this stuff to stack over a long period of time to lead up to animals, plants, animals, and life and all that.
Right.
So we will only ever observe ourselves in a world governed by causal principles. That does not mean that the world governed by causal principles was itself governed by a causal principle externally, right? Like it could have arisen spontaneously without a causal principle and then be governed by a causal principle, right? So like when you rephrase it, like if anything can begin uncaused, if you rephrase it as when anything can begin uncaused, then you realize the flaw, right? Like he's skipping over the location part of this. It's like, we're not saying anything can begin uncaused anytime, anywhere. We're saying that before the causal principle existed, things would begin uncaused, which is a logically necessary truth, because before the causal principle came to exist, obviously the causal principle did not exist, right? Like it's a logically necessary truth. And he would never get his mind around this. But that's the key. When he phrased it right there, you just notice switch between if and when, and you discover the mistake he's making. He's ignoring time. He's ignoring location. It's as if he can't get his mind out of the idea that if something can be true in principle, that it must be true everywhere all the time. And that's also illogical, right? We know we can prove that. We can disprove that just from cosmological science already, that the laws of physics have changed and the properties of the universe have changed over time. So like, so if you say like, well, if the Big Bang was true, then we'd all be melted at 1 billion degrees Kelvin right now. And it's like, no, yes, back then, if you were alive back at the Big Bang, you'd be melted by 1 billion kelvins, but it's cooled down since then. So it's not 1 million kelvins anymore. Stop claiming that we're predicting that it's going to be 1 million kelvins now. It's not what we're saying. Anyway, so it's trying my best to try and explain this as if I really need to. I feel frustrated, almost gaslighted. Like, do I really need to be saying this? You know what I mean? Like, I feel like I'm over-explaining this because I've been gaslighted on it by him so much now. I don't know what to do with it.
I believe me, I definitely understand that feeling. But it definitely seems there's some stuff that he says later that definitely makes it seem like he's very much stuck in some kind of state, as far as his argument goes, where something concrete exists and he never moves past that. And he specifically uses the word concrete when he refers to whatever's always existed.
Is that in a clip coming up?
I believe so.
Okay.
I believe I've got that captured in a clip. There's a little bit more here after he's been talking about his idea compared to the chaos theory idea. So
now, however, my argument, the way I formulate it, is not based on what can or cannot happen, but what would happen. I'm saying that if something did begin uncaused, then other things would begin to exist uncaused around us. The way I formulate it actually makes it resistant to some other objections which has been raised against that if you are arguing from Ken or Kut, the objections that have been raised by Almeida and others, which I discuss in my book. Yes.
Yeah, I think their argument is compatible with the sense that you use it here, where they're just saying it's almost like a stipulating if that set is not empty, then it would be infinite, and so that would be the sort of conditional premise that they would defend, and then from there the argument can kind of go through, and so then they would just argue, that the antecedent there is false, the category is empty, because they're if it wasn't empty, then there would be things popping into existence all the time, but that doesn't happen. So
pause it there. Much better articulated, but notice he's confusing if with when, right? So the interesting thing is that I agree with this because this is what my nothing argument actually is, right? My argument is if nothing limits what can exist, like before laws of physics existed to limit what could exist, before there's a causal law, for example, if nothing exists at that point, then literally anything can exist. And in fact, it's an equal probability that anything can exist. And you can show through a similar argument that he just articulated, the chaos theory argument, that infinite things should appear. And that is my argument. And therefore, you will have an infinite multiverse. It is an inevitable outcome of a nothing condition. And I go into more detail as to how that follows, et cetera, and how you define a nothing condition and all of that stuff. It's in my papers that I link to, that you have linked to there. So I agree with them. But of course, this means that all of this spontaneous infinite creation happened outside our view, right? It happened prior to the Big Bang, and these universes exist elsewhere. They're not connected to ours in any way. That's why they can't collide with our universes. They're separate. They live elsewhere, right? Like our universe is just one of the outcomes of this. And it is inevitable statistically, so this defeats the fine-tuning argument as well, because if infinite things can uprise uncaused, then, and they will, then our universe is inevitably going to be one of them, or something close enough to our universe structurally to produce observers, right? So, and Loke agreed with this in our debate, and he said, yeah, I think like if that's true, there would be an infinite multiverse. He said almost those exact words, and I said, yeah, that's my argument. He says, but then why don't we see it? And it's like, I've explained this multiple times. You can't see it. It's on the other side of a big bang. It's over. It's way, way far away. It's beyond our ability to see. That's why. So anyway, that's the difference here. And it's both of them are confusing if and when, right? There's like if things can begin uncaused. Well, no, you need to be saying when things can begin uncaused. Once you slip out of the if and back into when, then you start to see what's going wrong with their argument and why it doesn't hold as complete bollocks. So anyway, yeah.
I was just going to say, it seemed like what Cameron was actually stating about the chaos theory, the proponents of that, is that they suggest that because we don't see things randomly pop into existence now, therefore that infinite set that he was talking about has never existed.
Right.
And,
I mean, the argument is that basically they're saying if there was no causal principle, then they deduce infinite things should just randomly appear, which is true. You can ramify that in a more careful way, but it is, I mean, we're being colloquial here, so are they. But there is a really more technical way to word this where it is true. So yeah, if that's the case, then that results. And what they're saying is like, well, we don't observe it now, therefore it has to be false. And that's true if it were true that principle applied now, and it doesn't. And that's why it's not true, right? The prediction doesn't follow from the premise because the premise is that this condition doesn't exist anymore. It existed once upon a time, but doesn't exist anymore. We only see the aftermath of it. We can't see the rest of it. And so that's where they're going wrong. And it's just that confusion between if and when.